Look at any airport in the world. Tokyo, Dubai, New York, Sao Paulo, doesn't matter. Go ahead, pull up Google Images right now, and you're going to notice something so obvious that you probably never actually questioned it. Almost every single commercial airplane you've ever seen is white. Not silver, not blue, not the deep black that luxury cars wear, white. And when you start thinking about it, that's genuinely strange. Airlines spend millions, sometimes hundreds of millions, building their brand identity. They obsess over logos, terminal designs, gate colors, cabin aesthetics, and yet when it comes to the thing you see first, the thing the size of a building that flies over your house at 500 miles per hour, almost all of them choose the same color. Why? After this video, you will never look at an airplane in bright sunlight the same way again. Let's put this into perspective first, because the scale of what we're talking about is genuinely hard to wrap your head around. A modern wide-body aircraft like the Boeing 777 has a surface area of roughly 6,000 square feet. That's not the cabin, that's just the outside shell, the fuselage, the wings, the tail. We're talking about a surface bigger than the average American home, moving through the atmosphere at 560 miles per hour at 35,000 feet, where outside temperatures drop to negative 60 degrees Celsius. And that same plane a few hours earlier was sitting on a tarmac in Phoenix or Dubai, where ground temperatures hit 50 degrees Celsius in the sun.
The thermal stress alone on that surface is extraordinary, and the color of the paint, something that sounds like a cosmetic choice, turns out to be one of the most quietly engineered decisions in the entire aviation industry. Here's where the story actually starts. In the early days of commercial aviation, think 1920s, 1930s, planes weren't painted at all. The first generation of commercial aircraft were made of aluminum, and aluminum has a natural silvery sheen. Airlines actually liked that. It looked futuristic, it looked fast, and more importantly, not painting the plane meant it was lighter. Every pound you strip off an aircraft translates directly into fuel savings or payload capacity. So for decades, the default was bare metal, unpainted, polished. And some airlines, most famously American Airlines, ran with that look well into the 21st century. Their iconic silver livery was a deliberate choice to save weight. But something changed. As jets got faster, bigger, and more complex, engineers started paying much closer attention to what was happening to the aircraft's skin under sunlight. And what they found was genuinely alarming.
An airplane in bright sunlight isn't just getting warm, it's being cooked. The sun radiates energy across a massive spectrum: visible light, infrared radiation, ultraviolet rays, and dark surfaces absorb significantly more of that energy than light ones. This is the same reason you don't wear a black t-shirt on a summer day, but on an airplane, the consequences aren't just discomfort, they're structural. The aluminum and composite materials that make up modern aircraft have very specific tolerances. When the airplane's surface temperature climbs too high, and on a dark or unpainted fuselage in direct desert sun, we're talking temperatures that can exceed 70 to 80 degrees Celsius, the materials begin to expand. The adhesives that hold composite panels together weaken. The fuel inside the wings, which sits just beneath the surface, absorbs that heat and loses density. And the avionics, the electronic systems, hate heat. Every degree matters. But here's the interesting part. White paint isn't just about looking clean, it's about physics. A white airplane exterior reflects a massive portion of the sunlight that hits it. We're talking about reflectance values above 80% for good quality white aviation coatings.
That airplane reflective paint isn't just bouncing back visible light, it's rejecting infrared radiation, which is the primary carrier of thermal energy from the sun. So while a dark aircraft absorbs that energy and converts it into heat inside the structure, a white aircraft deflects most of it back into the atmosphere. The airplane's surface temperature on a white painted fuselage can be 20 to 30 degrees cooler than the same aircraft painted black under identical sunlight conditions. That difference, spread across thousands of flights and millions of flying hours, is enormous.
Now here's something most people have never thought about. Airlines don't just paint their aircraft once. Paint degrades. UV radiation, the same radiation that causes sunburn, breaks down the molecular bonds in paint over time. Aircraft UV protection is actually a major reason that aviation paint formulas are engineered to a completely different standard than house paint or car paint. Commercial aircraft coatings are designed to last years under constant bombardment from high-altitude UV exposure, which is more intense than a ground level because there's less atmosphere filtering it. The white pigment, titanium dioxide specifically, is one of the most UV-resistant materials available. It doesn't just reflect visible sunlight, it scatters and deflects UV rays in a way that protects the underlying structure. When you see sunlight reflecting off an airplane on a clear day, you're watching thousands of engineering decisions playing out in real time. This is where it gets really crazy. The weight argument for white paint is still very much alive today. A full paint job on a wide-body aircraft can weigh between 250 and 600 kilograms. That's the weight of 3 or 4 full-grown adults spread across the fuselage. Airlines that operate fleets of 200, 300, even 500 aircraft are doing the math on every single kilogram. White paint allows engineers to apply thinner coats compared to darker pigments, which often require multiple layers to achieve full coverage. Thinner coats mean lighter aircraft. Lighter aircraft burn less fuel. Over the lifetime of a single plane, that can translate to millions of dollars in savings. So the color of the aircraft isn't a branding decision, it's a fuel economy decision, it's a materials engineering decision, it's a maintenance decision. White is the color that makes every other system on the aircraft work better. And one more thing, this one tends to surprise people. White paint makes damage visible. When a bird strikes the nose cone of an aircraft, or when a ground vehicle clips the fuselage at the gate, or when a hailstorm peppers the leading edges of the wings, those marks, cracks, and dents are dramatically easier to see against a white surface than against a colored one. Dark paint hides hairline fractures. White paint reveals them. In an industry where a missed crack in a composite panel can cascade into a catastrophic failure at altitude, that visibility isn't a nice to have, it's a safety requirement. You're looking at heat reduction engineered into every square inch. You're looking at UV protection that extends the aircraft's operational life by years. You're looking at a color choice that saves airlines hundreds of thousands of gallons of fuel. You're looking at a safety system disguised as an aesthetic. White isn't the default because nobody thought of anything better. White is the default because after a century of flight, it turned out to be the right answer. Now here's something even more interesting. If white paint keeps an aircraft cool from the outside, what keeps the passengers alive on the inside when the temperature outside is -60 degrees Celsius and the cabin is pressurized to feel like you're sitting at 8,000 feet? The engineering behind aircraft cabin pressurization is just as quietly brilliant and just as invisible as everything you just learned. That one's coming next.